Welcome to another tutorial. Today we'll be answering a question on simple harmonic motion, and we have been asked to derive the formula for the total energy, and I'm just going to show you how just to do this question. Okay, so they want us to derive this formula where total energy represented by the letter W is equal to 1 over 2 kx to the power 2. Okay, so here they are saying a spring that obeys Hooke's law has a spring constant k. Show that the energy stored E in the spring when it has been extended elastically by an amount x is okay. So here, one thing that you will need to take note before everything is that they are saying it has been extended by an amount x. So we need to take note of this point. Now, one thing that you must understand is that for you to derive this formula, you must know the formulas that are under simple harmonic motion. That is for the displacement as well as the velocity. So for the displacement, we know that x is simply given by the amplitude A, then sine, okay, then sine WT. Some other books will even add something like this to represent phase. Okay, then for the velocity, it is just omega represented by W, then A, then cosine WT plus phase. Now we know that the total energy is equal to the kinetic energy plus the potential energy. So we know that kinetic energy is given by 1 over 2 mv squared plus potential energy is given by 1 over 2 k x squared. Don't confuse this formula with what is here. This is for the total energy. This is for the potential energy. From here, since here we have this velocity can be replaced with this formula here. So you can put the formula, and it's going to be omega A cosine WT plus phase squared plus, then of course we can also do some replacement here. Where there is x, we can replace with this formula, and it's going to be A sine WT plus phase squared. From here, we're going to have something like this: 1 over 2 m, then of course we have W to the power 2 for omega, like that, and of course we're going to have the amplitude to the power 2, then cosine squared Wt plus phase, plus we're going to have 1 over 2 k, then of course a squared sine squared Wt plus phase. Now when you reach here, remember that in my first tutorial I showed you that omega, okay, omega is equal to the square root of k over m, where k is the spring constant. Therefore omega squared is equal to just k over m. Okay, so it's k over m, meaning while there is this w to the power 2, we can replace with this expression here. So this is just the same as 1 over 2 m then of course we're going to replace with k over m, then we're going to have a to the power 2 cosine 2, then Wt plus phase, cross the bracket, then also here plus 1 over 2 k a to the power 2 sine 2 Wt plus phase. Then from here, of course, this and that can cancel. We're going to have something like 1 over 2, then this is going to be k a to the power 2 cosine squared Wt plus phase plus 1 over 2 k a sine squared Wt plus phase. Now upon reaching here, I think I can wrap this. Upon reaching here, okay, so upon reaching here, we can simply say that the total energy is equal to, we can factorize everything because we know that we have half here and half. We have k a to the power 2, we have k a here supposed to be power 2. So meaning we're going to have 1 over 2 factored out, then k a to the power 2 factored out, then we're going to put this in the brackets. We're going to put cosine the power 2 Wt plus phase, then plus sine squared of whatever is here. Okay, and press it there, and then we can close the brackets. Now remember in mathematics that this is equivalent to 1, meaning if this is equivalent to 1, and it simply means that simply means that our total energy is going to equal to 1 over 2 Ka squared. Okay. Now remember this statement, they're saying where the amplitude has simply been moved by some amount x, meaning total energy is going to equal to 1 over 2 kx to the power 2. So like that, you have simply shown how to derive the formula for the total energy, considering the formulas under simple harmonic motion. Thank you so much.